Hey Math 1, I'm back with the second part of section 2.2 notes. We're just going to go through the last three examples. Hopefully you guys will get some good stuff out of it. So, on example D, I used the left-hand side actually, I believe, showed up on your notes and a test from section chapter 1. All right, so kind of a review of things when you think about it. We're making sure that we distribute this negative, and you can almost think of it as like a -1, all right? Multiplying -1 times 4.5d to get rid of parentheses, okay? So that would give me -4.5d. And then when you multiply that -1 times 3, you get -3. Notice I didn't multiply by 2. It's 2 minus, not 2 times. So the 2 just drops down, and it's not being multiplied by anything. Over here, I'm going to take positive 3.2 and multiply that by 4. Now this maybe requires a little calculation off to the side. Here's my off to the side. 3.2 times 4 would be 4 times 2, which is 8. 4 times 3, which is 12. Make sure you insert the decimal where it belongs. There's one digit of decimal accuracy here, so go one end there. It's 12.8. And do the same thing again. 3.2 times -5. I know right away a positive times a negative is a negative. 5 times 2 is 10. Carry the 1. 5 times 3 is 15 plus 1. It's 16. Again, make sure you put a decimal down where it belongs. One digit to the right means one digit in. And I can just call it 16. I can call it minus, not 16.0, just minus 16. And then, of course, I multiplied by a d term, so it needs to be 16d. And that's our first step. Distributive property gets rid of parentheses. So now what we can do is collect our like terms. So let's get this 2, this -3, and this plus 12.8 side by side. So 2 minus 3 plus 12.8, okay? We want to get the d's side by side too. So -4.5d minus 16d. So I've got d's side by side and constants side by side. Okay, so maybe you've got to do some scratch work off to the side. That's okay. 2 minus 3 is -1. -1 plus 12.8. That's the same as saying take 1 away from 12.8. 12 goes down to 11. Still have the 0.8. So this is positive 11.8. -4.5d minus 16d. Same sign means you add the two together. So you take 16 plus, and if you're adding decimals, make sure you put the decimal lined up. So this is actually 16.0. This is 4.5. The reason is we need the place values to be stacked. You would not stack a 1's value with a 10's value. Okay? You got to, this is the 1's place. This is the 1's place. Make sure you stack them. So it's negative 20.5. And then you make sure you keep the variable if it existed before you added or subtracted. That's the D. So that was the subproperty. Now, here's an interesting trick that we can use from our new properties of equality. If I've got decimals in there and I want to get rid of those decimals, I can do this. I can multiply both sides by 10. So if I say use parentheses to indicate multiplication, and I say times it by 10, yeah, we can back that up with the multiplication property of equality. And then it moves the decimal place over 1, and then adds a 0 to whoever doesn't have a decimal. So multiplication property of equality would give me 118 minus 205D equals 220. And I guess you could call that the distributive property. Okay. So with that one, I've kind of run a little bit out of room, so I'm just going to go off to the side here. Subtract the 118 from both sides, and we would say that would be the subtraction property of equality. This one right here, because I subtracted 118 from both sides. So this is now 0 minus 205D, and then take 220 minus 18. So this is, sorry, you can't see it very well, but this is the subtraction property of equality. 220 minus 118. Well, I can't take 0 minus 8, so I got to borrow from the 2 to get 10 here. So 2, 1 minus 1 is 0. Don't have to borrow, so it's 102. Yeah. Then divide by negative 205 on both sides. That gets us down to 1 in front of the D. That's the division property of equality. And there's our final answer. Now, you could check to see if that's a reducible fraction. At this point, I really didn't pick a great example for the notes to, I guess, for you guys to figure out what the simplification is. This one ends up not simplifying. So kind of an ugly example, but what I wanted to show you is how last chapter, which was everything on the left-hand side, basically flows into this chapter. All right, hopefully E is going to be a little less strenuous. All right, it's got fractions, so there's only one more example left. Let me clean this up here. All right, so we're given 5/3 times e minus 4 times 4. I'll just write it down. All right, so I think I gave you guys complicated notes so that, you know, whatever I throw at you, it's not as difficult as what you see on the board here. So it looks like our distributive property is going to have to come first, pretty much like always if there's a if there's parentheses in it. So I'm going to take this -4, multiply it by 3, and I get -12. Take this -4 times -3/4. So I know right away a negative times a negative is a positive. But maybe I have to go off to the side to see what is 4 times 3/4. Okay, with an e attached to it. Again, the negative times the negative is a positive, so I'm not going to include that in my calculations up here. Well, you take a whole number times a fraction by putting the whole number over 1. Then you check for cross cancellation. Does 4 divide 4? Sure does. 4 divided by 4 is 1. 4 divided by 4 is 1. 1 times 3 is 3 over 1 times 1. It's 3. So it's 3e. -4 times this group gives me -12 plus 3e. That's super convenient for us. Because I'm adding to an e here. And then, well, I guess I have a 5/3 e over here. So that's the distributive property. Getting rid of parentheses through multiplication is the distributive property. I'm going to do two things at once. I'm going to move the 5/3 side by side with 4e. Okay? 3e plus 1e is 4e. I'm just going to calculate that right now. The 5/3 can move over here. It's a positive 5/3, so it's going to be a positive 5/3 here. Okay? And then the -12 is going to move over here. That's the commutative property and substitution happening on the same step. All right, so at this point in the problem, I want to simplify 5/3 plus 4. So I might have to do that on some scratch paper off to the side. 5/3 e plus 4e. I can add these two fractions together in two different ways. I think the way that might be easiest for you guys is to put the 4 over 1 and then find a common denominator between 5/3 and 5 over 1. So the e is just going to be over here. Times 3 would be to get a common denominator of 3, which would be 5/3 e plus 12/3 e. You get 17/3. So these two like terms give us 17/3 e. Still got the -12 hanging out over here. And that would be another like terms added together would be sub, if they're on the same side of the equation. All right, now, if you've got fractions over here and fractions over here, if you don't want to do this calculation over and over and over again, it might be best if we just found common denominators right away. What I mean by that is, if I put -12 over 1, and I find the same denominator for 1, 3, and 6, you'll see that there's a quick move to make the calculations easier. So, between 6, 3, and 1, if I multiply by 6 on the bottom and top here, I get a 6 on the bottom. Multiply by 2 on the bottom and top here, I get a 6 on the bottom, and I already have a 6. So you have a common denominator of 6. Now, you don't have to document that step with the proof property. But you could just say common denominators off to the side. Yeah. So here's why that's helpful. If I've got the same denominators, I can multiply both sides times 6, which is the multiplicative property of equality. Multiplicative property of equality, multiplied both sides by 6. And what that does is the 6 will cross cancel with this 6. This 6 will cross cancel with that 6. And this 6 will cross cancel with that 6 when you distribute them through all the way. So, I now have a negative 72 plus 34e equals negative 7 by multiplying everybody by 6. All three of these 6's cross cancel with the 1 6 out there using the distributive property. All right, now it looks like a nice, neat equation. You can add 72 to both sides. That's the addition property of equality. Ape. 0 plus 34e equals, okay, negative 7 plus 72. They're opposites, so you're going to subtract them. If you can't do that in your head, put the 72 on top, the 7 on the bottom, subtract it. Oh, it's 12 minus 7. It's 5. And then you're taking away from the 7 because you didn't have enough to create the 12. It's 65. Then you divide both sides by 34, which is the division property of equality. All right, and then 34 and 65, do they have a shared number that goes into both of them? The answer is no. So for the most part, I want you guys to put them as mixed numbers, but for this case, let's just keep it as 65 over 34. 34 does go into 65 one time, and there's 31 over 34 leftovers. But yeah, we're running 18 minutes on this video, and I think everyone's probably a little fatigued from seeing these problems. My apologies if these last two just seemed too overwhelming. What I wanted to do was show you guys there's a way to get rid of fractions by multiplying both sides by that denominator. And as we move forward in this class, you'll just see, oh, if I see fractions, find a common denominator, ditch the denominator, and it makes calculations a whole lot easier. Same idea with the decimals and multiplying by 10. All right, I'm done with 2.2. I look forward to your questions on this.